All right, hi ninth graders. I'm gonna go through today's notes, and as I go through this first slide, I want you to follow along with me, and you're gonna look at how we go through an entire example like this with a function, and we're trying to find all these different features. And then we're gonna do a couple practice problems together after this page. All right, so let's read through this top part. Eric rode to the park, had a picnic lunch, and then rode home. And you can see that happening here in the picture. It says he represented his trip in the graph below. All right, so if Eric rode to the park, had lunch, and rode back home, the first question is asking me to identify the interval where the function is increasing. Now, this is just gonna be like a basic introduction to this increasing, decreasing stuff, but I'm gonna take my red pen and I know that the graph is only increasing right here. Okay, but how do I talk about that as an interval? So where does this red line start and where does it stop? Now, another way to say that is where in the graph is it increasing? Okay, so I would say that it starts here and it ends here. Now there are a couple different numbers that I could use for that. I could use the coordinates 0, 0, and the coordinate, what's this counting by? On the bottom, it's counting by 3, 6, 9. Okay, so that would be 9, 6. So we could say from 0, 0 to 9, 6, but that's not the way that we're gonna have you write this stuff out in this math world. We are going to have you write this out as an interval. Now I'm gonna put some brackets around here because technically those are closed circles. Those are actual spots where the graph is increasing. And we would say that the interval where the graph is increasing starts at 0 and ends all the way to the right here at 9. So I'm gonna write this in interval notation with a hard bracket because it actually exists at 0, comma, all the way to the right with a hard bracket at 9 because it stops increasing at 9. The reason I had to stop increasing at 9 is because it gets flat right there. Okay, then I often get a question, my favorite mistake on these problems. Sometimes people instead try to do it like this. They say, well, that's from 0 up to 6. And they try to say 0, 6. Oh boy, that was a bad 6. Okay, this is a very common mistake. The reason we can't say that it's always increasing from 0 to 6 on the y-axis is because the y-axis covers an entire up and down section from 0, I'm going to draw this with dashed lines, all the way up to 6. Everything between those purple dashed lines is not increasing, which is why we don't want to use the y-axis. We always want to use the x-axis when we're talking about increasing and decreasing intervals. Okay, so a lot of talk about number 1. Let's talk about number 2. Number 2 says identify the interval where it is decreasing. Okay, so I'm going to highlight this in red now. It decreases and it starts decreasing at 24, stops decreasing at the input of 30. So neither of those has an open circle. That means they actually exist at 24 and 30. So I do hard brackets from 24 to 30. That hard bracket means that it includes the endpoints. Sure, you could have a little bit of debate whether or not 24 is actually decreasing there, but we're just gonna say it is. Okay, what is happening from the interval 9, 24? Okay, so I'm gonna get my pen out again, and it's saying from 9 all the way to 24 for your inputs. So if I look, this is counting by 3s, remember? So 3, 6, 9, here's 9. And it says go all the way to 24. Ninth graders, what's happening there? Well, it's not increasing. That means his distance from home is not getting bigger. It's not decreasing, so his distance from home is not getting smaller. So if he's not getting further or closer to home, that means he stopped. Let's look back at the example. He rode to the park, had a picnic lunch, and rode home. Guys, he's having his picnic. He's not moving there. Okay, number 4 says, describe the rate of change over 0, 9. We're going to use those intervals again, and delete that out. So I go from 0 all the way to 9. So the rate of change, that means find the slope here. How far up to the right, up to the right, up to the right does this go? Well, I could count up to the right 1, up to the right 1, up to the right 1. So the distance from home increases by 2 miles every And that is not going by 1 minute, that is going by 3 minutes. So I would say 2 miles per 3 minutes. And that would be 2/3 of a mile per minute, or 0.6 repeating miles per minute. Okay, what is the domain of this situation? This is a word that we've heard before. We've talked about domain. Domain is going to be all of the input values. And remember, our input values are the x values. So what can time be in this situation? Well, if I look at this situation, the first time value that was given to me was all the way over here at 0. That was the first lowest input. And then if I keep going to the right, all of these spaces have Eric on his bike or taking a picnic or whatever until we get to 30. So we would say from 0 to 30 is my domain. So that means I would write this out, and I'm going to use hard brackets again, 0, 30 with a hard bracket, because we actually have data at 0 and 30. Okay, so domain, that's going to the left and right. That is your input values. The range is going to be your output values. So that's going to be the distances that you can be from home. It's going to be the lowest distance from home and then the furthest distance from home, including everything in between. So the lowest distance from home was down here at 0. Both of these, 0 and 30, were both 0 miles from their house because they're both on the bottom. Then it goes up and up and up on both of these, and the furthest distance you have from home is 6 miles. So here my range would be from 0, the lowest, up to 6, the highest. Now, something kind of important about the range here, the range is the only time you are going to use the y-axis. Every other time here, we have used the x-axis to talk about these numbers. All right, let's do these last two problems. What's happening at f of 0? That means my input is 0. So at 0 minutes, how far up is it? Well, none. That's because Eric is riding his bike to the park. So I would say Eric is starting his ride. He's at home. Okay, so at f of 27, here's 24. 27 would be before 30. Looks like he's halfway home. He's on that downhill. So I would say Eric is on his way home. He's halfway there. All right, this whole page of example is supposed to be brand new to you. So if this felt super weird and kind of uncomfortable, if this was all new information, welcome to 4th term. Okay, so we are going to put this into a couple more examples. So now I want you to write down these next 4 examples on a sheet of paper. And I know that these are graphs. You can do a quick sketch of this graph, or just make sure that you've got these examples, or you can even, if you have graph paper, that'd be great. But if you don't, that's fine. You can just sketch this out and kind of see what it looks like. The first thing I'm going to talk about on this picture is something that we've discussed before, but we've never really defined it. It's called continuous and discrete. Now, in math class, I would use that word continuous, and you've heard the word continuous before, to mean something that doesn't break. Something that continues on the entire graph. So if I take my mouse here, you can see I'm following it along, and it never has to stop. I can keep following along this entire thing. All of the inputs exist. All of the inputs are part of the domain. So I would call this graph continuous because it doesn't have any breaks. Okay, so the domain, remember, domain is how far to the left the graph goes, and then how far to the right. That's your input values. So the furthest left this goes is all the way over here, 1, 2, 3, 4, 5, 6, at -6. So when I start this one, it's going to be a hard bracket at -6. However, as I follow this to the right, you should see something kind of weird here. This is not a filled in circle, it's an open circle. And when we have open circles, we can't use a hard bracket. We've got to use a curved parenthesis or a curved bracket. I don't really care what you call it, but this is to the right, 1, 2, 3, 4, 5, 6, +6 to the right, but I need to do a curved parenthesis there to show that it includes -6 to the left, but it does not include positive 6 to the right. Okay, now we're going to talk about range. If you remember correctly from our page before, we said that range is the only time that you're going to use the up-down distance, the y-axis. So if I look here, the lowest that this graph goes is at -3, and I don't see an open circle there. If there was an open circle, then we do an open parenthesis. I actually see that that spot exists. It doesn't have a solid dot, but it has a solid line. So I'm going to say that my range goes as low as -3. Okay, then I'm going to follow this thing up. That's not the highest point. This is not the highest point. This thing right here is the highest point. And there's not an open circle, so I'm going to say that that is closed all the way up to 1, 2, 3, 4, 5. So this goes all the way up from -3 to +5. And I'm going to do a hard parenthesis again. Okay. There's our domain and our range. Now let's talk about the x-intercept and the y-intercept. So on this graph, I'll mark these in green. Here's the x-axis, and this thing crosses the x-axis 1, 2, 3, 4 times. That means I'm going to have 4 x-intercepts. This first x-intercept is at -4, 0. This one right here, I'd have to guess, it's probably like 0.8, 0.7, 0. This one is to the right 2 spaces up 0. This one's to the right 5 spaces up 0. So look at all these x-intercepts. Bam! Apparently that was about 0.8. So -4, 0, 0.8, 0, 2, 0, and 5, 0. There are 4 separate x-intercepts, and I just list them with a comma between the different x-intercepts. Now, the y-intercepts, there are not 4 y-intercepts. There's only 1 y-intercept down here. That goes over 0 spaces, down 3. So my y-intercept is 0, -3. There's only the 1 y-intercept. All right, that was example 1. Let's look at example 2. Here's example 2. Now that first question I'm gonna keep asking you, is it continuous or is it discrete? So can I follow this thing along with no breaks? No, that is not possible. If you see, I have to jump on my x-axis to get to the next section. So this is not continuous. This is what we call discrete. Separate, discrete sections here. Okay, the domain is a little bit weird here. You're tempted, I'm sure, to say that the domain goes from -6 all the way up here to +6. The problem though, there are some breaks in here. It doesn't cover every inch of space from -6 up to +6. So we have to look at those breaks and actually figure it out. Here's a break. So it goes from -6 and then it stops at -3. Let's write that in here. -6, -3. That's the first section of the domain, from -6 to -3. All right, let's go to the next section. It picks up again at -2 and stops at 0. By the way, yeah, I'm drawing these really weird things. That's just for me to be able to see where stuff is. Okay, so we went from -2 to 0. This is still the domain, but it's a separate one. So I'm going to say -2 all the way to the right until I reach 0. And then let's look at the next one. It goes from 1 to the right all the way to 3 to the right. And notice I'm putting hard brackets on all these because all of these circles are filled in. If they were opened up circles, then I would put soft brackets on them, but they're not. Okay, so we said that one went from 1 to 3. And then our last section goes from 1, 2, 3, 4, all the way to the right to 6. So I'm going to say hard bracket 4, 6. Okay, there were 4 separate sections and my domain has 4 separate intervals. It should match up like that when it's discrete. Okay, so now the range, let's talk about the range here. Oh boy, let me get rid of these things. Okay, so the range is actually not as difficult as the domain there. Remember with the domain, we said that there were these breaks where there was nothing in this entire break and there's nothing in this whole break or this one. So there were those 3 little breaks there. But when we get to the range, I want you to see if there are any breaks. So we start down here. The range, remember, goes as low as it can go up to the highest point. So here's the lowest point, and that's all the way down here at -2. So I would say that the lowest my range goes is a hard bracket at -2. Okay, now I'm gonna follow this up. Notice it's touching every point going up, and then I might be tempted to stop here, but the problem is it doesn't stop at 2. Do you see how 2's right here? Well, look, this one picks up at 2. That one's at 2. That one's at 2. So it doesn't actually break in the up-down distance. If I were to take a ruler, which I don't have a ruler that I can hold up where you could actually see it, but look at my mouse. My mouse is going across here. It's hitting stuff. It's hitting stuff. It's hitting stuff. It's hitting new stuff now. Oh my goodness, it's hitting new lines. And this line continues on from that 2 up until the highest point, which is at 4. So this range doesn't actually, quote unquote, break. That means I could never actually draw a line or do that little squiggly thing that I had done before. I can't do that for the range because there's never a spot where I could draw a line like here. Bam, it crosses that point. Okay, if I tried to draw, maybe I try to draw a line like right here. No, it crosses there, it crosses there, it crosses there. So I can never draw something to break up the range. So my range actually didn't have any breaks. It's just one interval. Okay, let's talk about the x-intercepts now. X-intercepts, that's everywhere that it crosses the x-axis. 1, 2, 3, and 4. There are 4 places that they cross the x-axis. So I should have 4 x-intercepts. -6, 0, 0, 0, to the right 1, 0, to the right 6. Oh, that shouldn't be 6, 0. That should be, I'll just change it with my pen. That should not be to the right 6. That is to the right 5, 0. That looks so beautiful. I've never seen anything quite so beautiful in my entire life. Okay, let's do the y-intercepts now. There is actually only one y-intercept, that star, and that is to the right 0, up 0. Okay, we did our second example. We got 2 more, and then I'm going to throw you out to do your homework for tonight. So make sure that you're following along. Ask questions if you've got them, and by ask questions, I mean email me. Okay, so this one was discrete because it had breaks. Let's look at the next one. Does this have any breaks? No, it does not. Okay, so we know because there are no breaks in the graph, it's continuous. I'm going to have you push pause and try domain, range, and the intercepts. Try it. Go. I bet like half of you did pause, and some of you might have said, no, Ms. Johnson, you'll never know. You're right, I'll never know. Okay, so let's talk about the domain and range here. Domain, how far to the left and how far to the right. Oh my gosh, Ms. Johnson, there's no dot on the end. You're right, there's not a dot on the end. What does that arrow mean? How far to the left does this graph go? Well, it goes forever to the left. Okay, how far to the right does this graph go? Forever to the right. We have numbers for that. Now, if you try to tell me over here goes to infinity, you're wrong. That's not regular infinity. Regular infinity is a positive direction. So that means the furthest to the left that it goes is negative infinity. And the furthest to the right that it goes is positive infinity. And that looks like this. Domain is from negative infinity, comma, positive infinity, because it goes forever to the left and then forever to the right. Okay, make sure that you put the negative infinity on the left side. It makes a difference. Okay, so now let's talk about the range. How low does this graph go? Well, technically, this thing right here is the furthest down point. Wrong. That arrow means it goes on forever downward. Okay, so that's going to be negative infinity as the lowest point. This thing here is saying forever upwards. So positive infinity is the highest point. Bam. Because of those arrows, we had to introduce infinities. Okay, x-intercept. Where does this thing cross the x-axis? Let's get a pen out. X-axis, that's the one that goes across. Okay, we are going to have to estimate. So that is 1, that is 2. Can we say like 1.5 up 0? 1.4, oh my goodness, that feels a little nitpicky. There's a question mark after it though. Okay, so apparently 1.4 comma 0, that means I go to the right 1.4 spaces, up 0 spaces. Okay, now let's talk about the y-intercept. I go up, I have no idea what the estimate's gonna be here. That looks a little higher than half, let's say 0.6 up comma 0. I said it backwards, but this is correct. To the right, 0, up 0.6. If you said 0.5, then you're probably a normal human being who likes to guess normal human being numbers. That's okay. All right, we've got one more example. The first question I'm gonna ask you, as always, is continuous or discrete? Okay, so on this picture, continuous or discrete? And then I want you to do domain, range, x and y intercept. Press pause if you're honest and try this on your own first. Welcome back, my honest people, my dishonest people. Shame on you. Okay, so this thing right here, there are lots and lots of breaks in it. That makes it discrete, okay? So discrete, this is weird. You're not gonna like what I show you next, but I promise I won't give you a ton of examples like this on your own. We'll practice these together instead. Okay, so here's what I'm gonna say for the domain. The domain, I know you're tempted to say from here to here. The problem is when we say from here to here, we mean everything in between. Ninth graders, was everything in between included? No. Only a couple dots were included. So we actually just list out the different numbers. So the first number is, what is this counting by? Oh my goodness, do you see how every other space is 1? So here's 1, here's 2, here's 3. So this is 1. That means this dot right here is a little bit lower than 0.5, so let's say like 0.4. This one looks like it's at 1. This one's at 2, 3, and 4. This is how you do this. You just list out the numbers, just those numbers. And then you see these weird squiggly brackets? You can panic for like 2 seconds. Okay, you have to be done panicking now. It's just a mathematical thing that they do. They do these squiggly brackets to say, I'm listing out the numbers instead of telling you an interval. So 0.4, 1, 2, 3, 4. You just have those numbers. Okay, so those were the domain numbers. That is all the inputs. Now let's talk about the range numbers, the outputs. The lowest one is like right here. It's like halfway to 0.5, so 0.4 maybe, then 0.5, 1, 2, and 3. So the range numbers, it's just the number 0.25. Now for those of you who are panicking right now because you don't know where I got that number, this 0.25 means that this dot right here is 0.25 of the way to 1. Okay, so this 0.5 is talking about this dot. It's halfway to 1. This 1 is talking about this dot. It's at 1. The 2 is talking about that dot, and this is just really fun to draw these giant red lines. The 3 is talking about that dot. Okay, don't know why that moved, but now I'm gonna get rid of those, maybe not. Okay, let's now talk about the intercepts. X-intercept and Y-intercept. This was a tough one. Sorry I made you try this one on your own. Where does it cross the X-axis? That one's kind of close, but it doesn't actually cross. So none, there's no X-intercept, which means the Y-intercept, there's none, no Y-intercepts. Okay, so we just did continuous or discrete, domain and range, X-intercept, and Y-intercept. We're gonna talk more about these on day 2's notes, but you're gonna do some practice through a Canvas quiz today. You are allowed to do 3 tries on that Canvas quiz, so try to get 100% by the end of it. Good luck. Look back at these notes, ask me or Mr. Bodley if you have any other questions. Yeah, we'll see you later, my lovely, lovely people trying to remember how to stop.